very much, Sean, for the introduction. Thank you all for the applause. Thank you to the other presenters for this wonderful evening. It's been a lot of fun. I'm very glad I get to be the final presenter for tonight. My name is Robin. My supervisors are Duncan Lee, Nima Dean, and Eli Jack. We are all from the School of Mathematics and Statistics. We are all statisticians, and I'm also a singer-songwriter. And so tonight I'm going to present to you my statistical research, but I also sing to you 3 songs that I wrote just for you and just for tonight. The research that I'm presenting is on national lockdowns in England, so this is COVID related. What we're looking at is how did the COVID-19 mortality risks vary geographically after these 3 national lockdowns that we've seen in England in the pandemic. I heard there was a laptop. Oh no. So first of all, what we look at is England as a map. You see all these outlines here. These are local authority districts. These are the aerial units from our study. Now, I'm sure most of us haven't been to a lot of these local authority districts. By raise of hands, who of you has at least been to London? If you've been to London, raise your hand. Wonderful. See a lot of hands up? So we're going to look at a special case, just looking at London here. So this is the outline of the city. We're looking at just one specific week. So this is 1 week during the first wave of the pandemic. And actually, instead of looking at all of London, we only look at 2 local authority districts, which are Tower Hamlets and Havering. Tower Hamlets saw 59 COVID-19 deaths during this week. Havering saw 57. Now, how do we compare these 2 numbers? Well, first of all, we should probably learn a little bit more about these local authority districts. Here's Tower Hamlets. You might recognize this picture, Tower Bridge. This is part where it gets its name from. The Tower of London is also in here. Tower Hamlets has a pretty young population. It also has a very ethnically diverse population. There's a very big proportion of a Muslim community, a large Bangladeshi community living there too. If we now compare Havering, looks a lot different. Much lower population density, much older population, and Havering is actually the least diverse population in all local authority districts in London. So 2 very different local authority districts. So how do we compare these numbers of deaths? How do we compare these numbers of deaths for these 2 local authority districts, given that they are such very different local authority districts? Well, what we use is called standardized mortality ratios, short SMR. Basically what that is you take the observed numbers, which we've seen before, and you divide by the expected number. Now the expected numbers you can get from national mortality rates, which we then can apply to the specific population that you have in these local authority districts. Now, the national rates are not available for a lot of variables. 2 pretty common ones are age and sex. For age, we've seen that mortality risk for COVID was much higher for all the age groups, so we probably want to account for that. With sex, we've seen that males are at higher risk than females of dying of COVID-19. And so now you can take age and sex specific mortality rates from a national level and compute expected counts depending on the specific demographics from your local authority districts. If that was a bit much, basically all you need to know is the 59 deaths for Tower Hamlets corresponds to an SMR of 14. This tells you the 59 deaths were 14 times more than we would have expected. Similarly, the 57 deaths for Havering are 6 times more than what we expected. So both of these numbers are much higher than we'd like them to be, but we can also see that the observed number of deaths in Tower Hamlets was much more extreme than that of Havering. And that is because the population in Tower Hamlets is so much younger overall. Now we can see how these SMRs look like over time. So you can see this red line here, which is an SMR of 1. That means that the observed is equal to the expected. Whenever you're above this line, you have an increased risk, so observed is higher than expected. Whenever you're below this line, you have a decreased risk, observed is lower than the expected. Now, unfortunately, we see these 2 peaks. So at some point, SMRs were rising. We don't know exactly why. It's kind of the dynamics of the pandemic. What we were interested in is seeing why did they go back down. And so then we saw these national lockdowns. So these intervals here are the 3 national lockdowns in England. And especially for the first and the third, you can see that roughly 3 weeks after the lockdowns were implemented, these SMRs start to decrease. And now one more note before we get to the singing. You can also see that there's a lot of variation in these SMRs. That is because the observed and expected counts can be quite small. And so instead of working with these raw SMRs, we fit statistical models. So these smooth these SMRs over space and over time to get more robust estimates. And so on the remainder of this presentation, you will see risk or estimated risks rather than SMRs, but these are just smoothed versions of these variables. So with that, I'll grab the guitar, and Jamie is going to be doing the clicking for me. Thank you. Right. So I have 3 songs. The first one is at the national level. Let's go. You can see that the risk increased in the first 3 weeks of lockdowns. 1 and 3, 1 and 3, 1 and 3. The risk increase was followed by a decrease, and it took about 8 weeks to reach a risk of 1. The risk increase was followed by a decrease, and it took about 8 weeks to reach a risk of 1. Now what is wrong with lockdown 2? There is no increase, no decrease, so what did this lockdown do? Well, what did this lockdown do is a good question. So for the first and third lockdown, we see these increases in the first weeks. That is because people got infected before lockdown, but then they died during the first few weeks. So there's a delay. Generally, we don't want this peak to be very high, because if this is very high, the lockdown was probably implemented a bit late. However, if we don't see any increase, that kind of suggests that there might not have been much of a new wave in terms of mortality. So for the second lockdown, it could have had other impacts. For example, fewer infections, fewer hospitalizations. In our data, we don't see that. So for us, lockdown 2 didn't do a whole lot. But we will look at regional results. So here we have now 9 regions of England. Makes it a bit easier to summarize some results. And so you can see on this plot these risk curves for these 9 different regions. Now this is a lot to look at, so we'll look at a fewer of them one at a time, and we'll do so again with some. London town, what went wrong? Your risk was so much higher. But at least it decreased quickly once the lockdown had begun. Only in lockdown 2, your risk was pretty low. But once the lockdown ended, it started to grow. And in lockdown 2, the northern regions had the slowest risk decrease. In lockdown 2, we don't know where the changes are. And in lockdown 1, the southern regions had the quickest risk decrease. In lockdown 3, they all look similar. Thank you. So yeah, for the last one, it's a bit harder to see. But they all started at very different levels. And if you account for that, these shapes are generally pretty similar. Okay, one last bit. We looked at a local authority district level. There's 312 of them. So we can't really look at all of them at the same time. So what we did instead was a cluster analysis. So the idea here is that you take local authority districts and put them into groups, such that the risk trends after lockdown are more similar for those LADs that are local authority districts that are in the same group, and most dissimilar for local authority districts that are in different groups. And so we did that for 2 to 10 different groups. The best results we obtained were for 2 groups. And so these are the results, also most easily interpretable with just 2. So that makes it easier for me to write a song about it. And I'll sing that one last song for you. I apologize if I sing it correctly, it's a bit of a banger, so you might take it home later. There were 2 clusters for lockdowns 1 and 3. The first at higher risk, the second moderately. There were 2 clusters for lockdowns 1 and 3. And now we wanna see what do they look like on the map. In lockdown 1, the risk was higher in the urban areas. And lockdown 3, the risk was highest in the southeast. In lockdown 1 we see an association between higher risk and deprivation. In lockdown 3 we see an impact of the Alpha variant, which started spreading in Kent. And the risk was higher in the urban areas. And the risk was highest in the southeast. And the risk was higher in the urban areas. And the risk was highest in the southeast.